Okay, hello. Today I will speak about ref returns, which is a new feature in C# 7 something, I don't know, 7 probably 0. And the main idea behind it is that if you have a structure, or basically anything that's not a reference type, which is basically a structure, you might want to return a reference to it if you can. By default, if you create a structure, it's created on the stack, and that means that if you return it or if you pass it to a different method, it's copied because it's not accessible from the stack, and that brings performance penalty, memory penalty. So usually you don't care, but in performance-sensitive code, you probably want to have like a one only instance somewhere at some place and return it back to the caller or to any other place that's accessible to the caller. Because it's about ref returns, we are talking about returning back to the caller. I will start by creating a simple structure, which I called my struct. It could be empty or anything. As I was playing with it, I created a structure with one field, and then I was like, okay, I need something to assign to a field. It would be easier to create a implicit cast, so I created an implicit operator that takes an int and assigns it to the field itself. But it doesn't really matter what's inside the structure. It's about what the structure itself is. So that's the structure I will be using. And let's start with the first one to explore. The ref return works like a normal modifier for the return. So if you are returning something from the method, you can put ref in front of it, and that means that you will be returning reference to in case my struct in my case. If you don't put it there, it's a normal method, nothing specific happens, it's just a ref. The same if you are then calling a ref and some value, property, whatever, you need to put ref in front of it, else the compiler will complain. So the first one I have here, I already pasted the classes and the code there because you don't want to see me type, because I'm a pretty slow typer. I create an array of structures with some values. Doesn't really matter what the value is. And then I try to return reference to one particular structure in this field. And this obviously works because compiler is not putting red squigglies there, because the array is created on the heap. So I can create a reference to some item on the heap itself and return a reference to it. So if I would call this method with some index, it would return me a reference to a structure in this array, and I can then do whatever I want with it. It's not being copied, it's a reference. This is probably the very basic stuff that you can create with it. So let's go into a different one, and this is the same method, and I will create the same return value. It's again the my structure, and it's again the reference. But now I will create the array locally. Again, this works, no red squigglies, because the array locally is again created on the heap. I can return a reference to any item in this array, so that's fine. The garbage collector will figure out, okay, somebody is holding a reference to this array, to this item in the array, so I cannot garbage collect it. It will be held until I just lose the reference to it. But it means if I have a local array, and I'm returning a reference to some item because it's located on the heap, then obviously the compiler should complain if I create a reference to a local field, because if it's a local variable, because it's a local variable, then of course it's on the stack, so I cannot create a reference to it, because if I return from the method, the stack for the method is destroyed. So let's try it. So I will first create a reference with the structure, and obviously the compiler is complaining and say, oh, I cannot create this for you because obviously it's not going to work. So yeah, probably I'm missing the modifier. Obviously I'm. So I'll create a new one and I say, yeah, you need to have an assignable variable, which this one is not, because I'm creating a new something and I cannot reference something that I just knew. So the compiler is obviously complaining. So let's build on top of this. Obviously, the return is not working, but it's because of the error on the line before. So let's build on top of it and try something else. If I create a static field in the class, that should probably work, because if it's a static field, then I have a class. The class is a static field. Static field is obviously on the heap, so it should work, and indeed it works. There's a return fi. Compiler is not complaining. So far so good. But what if I remove the static? So I have only the struct, which is a normal private field of the class, and I can create a reference to this one because it's a class. Class is allocated on the heap. The field is obviously field of the class, again on the heap. Should work, right? Everybody with me? Okay. So what if I change the class to a structure? So I create a structure with a field in it, and I want to return a reference to this variable. Is it going to work or not? Can the compiler do some magic to make it work, or should it work by default? Okay, who says yes? Nobody. Who says no? Good. You probably can see that there is a red squiggly somewhere here on the scroll bar, so that was like probably cheating. Who was cheating? Hey? Okay. Yeah, obviously it's not going to work because you have a structure. Structure is on the stack. If you create a field in the structure, it means it's still on the stack. So compiler is complaining and says, yeah, you can only have like instance members by reference or this. That's it. But thinking about it, what if I create a structure with a static field? Right? Is that going to work or not? Everybody's looking at the scroll bar, but it's clear, right? I can see it. Well, let's try it, because I create a static field in the structure, and then I create a reference to it, and obviously it's working. So where is this static field actually allocated?
Otherwise it wouldn't work. So.
Yes, it's on the heap. It's a special part of the heap that's actually used for these static fields in structures. But obviously it does work. So that was like, okay, what I can return, what I can't return. It's pretty simple. I will just create something that I can have a reference to it. So it cannot be on the stack. It needs to be somewhere in the memory. So in the .NET on the heap. And once I have anything that's on the heap, the compiler will happily return a reference to this one, and the caller can use it, modify it, whatever the caller needs to do with it. As long as it's on the stack or place that's not on the heap, compiler will complain, and you cannot like try to break the compiler. It will happily say, no, you are doing something wrong. So let's collapse this one and try something else. What if I pass the structure as a variable? So if I do the array and then I do the index, obviously there is no red squiggly, so it's going to work. But why it's going to work? In the method, I have no idea where this one is allocated. I cannot say whether it's allocated on the stack or on the heap, right? I can't, because it's just an argument to me.
It's an array.
Sorry?
It's an array.
It's an array, yeah, but I have no idea where it's allocated. But it's working, obviously. Why? Well, it's pretty simple. If the caller was able to pass me this array, then I can pass reference to something in the array back to the caller, because I don't care where it's allocated, but the caller has access to it, so I can create reference to it. So if somebody is like calling this method with the array, I don't care where it's allocated. It might be allocated on the stack. I don't know how he did it or she did it. It's fine. I'm returning back to the caller, and the caller has access to this data, so I can do it. That's actually the simplest form that you probably find in the documentation or anything. This one. To really try whether I can like break it, probably, I created an unsafe method, so I can create the array really on the stack to see like, is the compiler cheating or is it working? So I create an unsafe method that takes a pointer to the structure and I can index into it. And I'm calling it again in the unsafe code. Let's try this one. There it is. And I have an array that's allocated on the stack. Really like brute force, do it on the stack, and let's try calling it. And where it is? There it is. If I call it, obviously it works. If I remove the reference, then it's obviously the normal calling, and the compiler doesn't do anything special. But if I do the ref modifier, I will get back to this in a minute. Then I'm getting the reference, and everything works just fine. So yeah, the compiler is not stupid, but it's also not smart. It just follows what I did. Give me the reference. The caller has the value. I can pass the reference to a value that somebody gave to me in the method. So what does it mean if I return a reference to some array or something? Let me collapse this one, and leave this one. So I will be playing now with this method only. So it's not unsafe code, it's a normal C# code. I have an array of structures and I'm returning a pointer to some item in the array. And here at the beginning, I create a structure, I put it into an array because it needs to be an array, and then I try writing to the console the current value of the I, which will be 0 because that's the default value. Then I will of course try from an array. No surprise, it will be again 0. And then I call the method, give me the first item, give me the index 0, and I modify it. Now the question is, what the local.I will put to the console? Any guess? Okay, who thinks it will be 2? Nobody, okay. So what about 1? Nobody. 0? Was it yes or no?
Partially yes. Že tam není, jo, takhle. To nemyslím.
Okay, so probably 0, right? What about this one? 0 or 1? Now I'm indexing into an array, and then I'm getting the field back. 0 or 1? Okay, who says 0? And the rest says 1, right? Well, who says something else than 0 and 1? Let's make it clear. Okay, nobody. Well,
We work binary.
yeah, good. What about now? Okay, well, we can run it later. Well, let's try the same code with the ref modifier in front of it. It's the same code. I will again put like 1 into the field and then return this and this. So this line, 1 or 0? 1. Really? So let's do it one by one. I have an array which contains one item that's the local field. It's on the stack, and the array will be on the heap. So basically, this one will go on the heap as well because it needs to be referenced from that, right? Okay,
Local bude na heapu.
this one's on the heap or on the stack. Heap, stack.
Stack, but it will be copied to
Yes, correctly. Then I have the array that will be on the heap. So far, so good. So I call this method, and the method itself has this signature. So it takes an array, nothing specific, just an array and an index. I'm saying give me the index 0 from this array. And I'm returning a reference, which by default says something. I'm returning a reference to an element in this method. If I go this one, I'll just do like square brackets, and that's it. And I assign it to the x2 variable. Then I assign a 1 into the x2 variable, which reference is. Now the answer. What's the x2? Where it points to?
the heap.
Yes, because it's a reference, so it goes on the heap correctly. And is it pointing to this, or anything else?
The this one you have selected right now.
Sorry?
The this one you have selected right now. Inside the array.
Yes, correct. So if I assign a 1 into x2, which points to whatever we just said, then the local.I will show what?
0.
0, correct. This one,
1.
1, perfect. Let's try it. Doing something?
Errors.
It's not doing anything. Why it's not doing anything?
To je ta magie.
To magie.
To bych strukty zakázal.
Ah, yeah. That is my problem. Boom!
Jako jestli se bavíme o tom též, samozřejmě. Můžeš použít strukturu.
Ale to jsou to speciální.
Dobře, tak point je taky struktura, můžeš použít point P, ale musíš psát rovnásení point. Na to musí jako tak ještě s tím var, že to tak jako vypadá.
So this is the result. Obviously the first one returns 0, because that's the first two. And we have the call with the non-reference returns, which even if I'm returning the reference, I can call it without the reference, then the compiler will behave the same old way. So it's again 0, 0. Then I get the reference, assign the x1, then I will obviously 0, because that's the local, that's on the stack. And then I get the 1, because that's the array 0, which is the same as the x2. Boom, I get the 1, and that's the same for the unsafe code. The unsafe code behaves exactly the same way. It's just where it's allocated. Nothing really specific about it. Questions? Okay, then thanks for your time.